Hello and welcome back. I'm sure you enjoyed that lovely break. Let's get in to learn about today user receive program. So let's get in. I open the IDE as you can see. We're going to start from scratch. So I'm going to go to File, New STM32 project. We're going to set the target selection. So it's downloading the files. Just one sec. Once it's ready, then we can select the target selection. Still loading in the background. It will be ready shortly. I'll close all of this so you won't get confused. File, new STM32 project. Sorry, I clicked too many times, so it's okay. Here we are. So we got to select the board. As you know by now, we are using Nucleo F411RE. So select that board. Select that board. Click next. Then give a project name. Today is day 15, so I'll replicate that. Day 15. You're going to learn USAT receive today, and then hit as empty for targeted project type. Finish, and this will create the files as you can see. Day 15. Okay, we are ready, and now we have to go to main.c and start to write our program. As you know by now, these are all for reference. So this is the file name, and this is the author who has written the program, and this is to tell which part of this long program your coding will be written. So this is how they write in the industry, and also they will leave the license comment as well, just for some important function. So I'll delete everything that has already in there so it won't confuse you. Delete all of that. Okay. To generate the .elf file, I will build the project, so it will generate that .elf file, and also I will set the debugger, and then we'll go and copy all the registers, and then we'll start the program straight away. Okay, .elf file is generated, which is good. Okay, and I'm going to right click, debug as. I'm going to set the debug configuration. So by default it won't show. You need to double click on that, and that will change to the today's program, usartrx, usartrx.elf. Go to debugger, enable the st-link and the serial wire viewer, apply debug, and this will change from C++ perspective to debug perspective, and you can go and copy all the registers in these special function register SFRs. So let's wait. It's still doing its job. 89%. Yes, click switch. This will change to debug mode. Let's keep it in debug mode, and now we're going to watch the special function registers. So view, go to special function registers, and then we'll start from first you need to enable the AHB1ENR. that's for the GPA over port A. You need this register and this address, so that is what we will start first. first. Uint 32 underscore t, and you need to declare the pointer and copy that register name, paste it, and you got to typecast it here. Uint 32 underscore t, and that's the register you need to copy as well. Control C, Control V. Okay, so now you need to set the USART to enable, so I'm just copying that. So for the USART enable, you already learned that it's connected to the peripheral bus 1, so you need this enable to clock for the peripheral bus. So copy this, APB1 ENR on a pointer, and you have to copy this address as well. So copy that and paste it here. That's good. So now you can go and copy this again. Now you need to set the GPIO modder. So for that you have to go to GPIO A. You need to load the mod R register. So you need this address, modder register, GPIO modder. So you're going to write as GPIO A mod R register, mod R register, and you need this address of the modder register. Control C, you come here and copy that. Yeah, so that's the modder address set. Now also I'm going to show the output in the output data register. So that's where the LED is connected, so you need this GPIO modder. So GPIO A output data register, that's where the LED 2 is connected, so I need this address as well. It's 14. Control C, copy that in here, paste it. Okay, so now we're going to set the USART to. So for that you have to configure the alternate function register low. So A for L, you got to set that. That is the function type. So you need to copy that. You need to go here and GPIO A AFR, AFRL. The alternate function will be in USART2. USART2. GPIO A, alternate function is this one, A for L, and that's the address 0 class 2020. You need to copy that and paste it here, yeah. So now you need to set the USART baud rate register, BRR. Go to USART. You need to set the baud rate register, and you need the status register and the data register and the control register. So the next step is you need to set baud rate generator. So I'll just copy that and paste it there. AFRL. Next step, AFRL. So now we'll set the USART registers, configure all the USARTs. We are using USART2. I'll start with the status register first. I'll go by the order, like here, like it says. Status register 4400, copy that, copy and paste it here. And then the next one is USART data register. This is where you fetch the data from for receive or transmit. So you need a data register for that. And the data address is 4404. Copy this and paste it here. And the next one is baud rate register. You got to copy this 4408. 4408. Copy that. Paste it here, and this is the USART2 for baud rate, setting the baud rate to 9600. USART2 underscore baud rate register. And the last one is control register. USART2 underscore control register 1. And for control register 1, this is the address you got to take. 440C, control C, come here and paste it. So now we copied all the appropriate registers from the register map, and we got all its addresses that we need. So it's all copied. So now we'll go and write initialize first. Let's go and initialize the USART first, and then we'll write the UART initialization code first. So to do that, void USART2 underscore init off, and we're going to write the USART initialization function straight away. So init Okay, so let's start to write USART init straight away. It's argument void. Okay. So what is the first step? First step is to enable the clock access. First enable the clock for GPIOA. So to do that, you need this set. In order to set, you just have to just simply R that register. Unsigned. Set the register 0. Okay, so the second step, you got to enable the bus for the USART2. So the second step, Control V, is to enable the clock for USART2. Let's do that straight away. USART2. And this will be this register. Control C, Control V, and you got to shift 17 times, as you would know from previous session. If not, I'll show you shortly after I finish this. So now you need to set the output moder. The output moder, you got to configure PA2 as transmit and PA3 as receive. So you got to do that. And PA5 as you're going to set that as an output, so you got to mention all those. So I'll copy this. Control V. Okay. Third step is to enable the GPIO, configure the GPIO alt function, configure the GPIO A to alternate function. First we'll do the PA2, set PA2 for user2 underscore transmit. So this is what we're going to do. To do that, you need to use this port register, port moder. So you got to use you can't write 0. I'll explain. You need to negate this, and then set 1 unsigned, fourth bit is 0, so you got to write the 5th bit as well. So copy this, copy, paste, and to set you have to just R it. That means its value is 110. Okay, so now we set the PA2 for USARTX. So likewise, you have to set PA3 for USART receive. So copy this. I'll paste it here, and I'll start USART4 alternate function. Set PA3 for USART receive. Receive. So you have to use the same port moder. So this will be, I'll show you where it is now, is the time. So you got to go to a reference manual, and you need to go to GPIO register RCC. I'll show you from here. Okay, this is the RCC control register. We don't need this. We have to go to HB1 ENR. So this is to enable the clock. This is the reset counter clock, as you know, reset clock control register, counter clock, reset and clock control. Come on, show. Yeah. So the first bit, the 0th bit, we enable for clock. So we are using GPIO. That's why in the program we enable this one unsigned, the 0th bit as 1. So we enable the clock for GPIO. Now we're going to enable this for the register. That's the APB1 again. You click the content and go to APB1 ENR, APB1 peripheral clock, APB1 ENR. So if you go here, we are shifting it to 17 times. So you need to enable the USART2. That's why we are shifting 17 times. So this is what this means. 1U17 left shift means you setting that bit as 1. So that's what you're doing. And then now you configuring the GPIO port A mode to alternate function. As you know, that mode can be used for that port can be used for input, output, alternate function and analog, but we are using USART, so it has to be an alternate function, and we're using that for transmit. So you need to go to GPIO A, again go to contents, go to GPIO A, GPIO general purpose registers. So this is the port mode register we need. So as you know, this is PA0, PA1, PA2. So this is the bit we are setting for transmit. This is the bit we are setting for receive. So we have written 1 0. You're setting bit 5 as 1, setting bit 4 as 0. That means 1 0 you're going to write as an alternate function. That's why we are writing as 1 0 here. And also we're going to use PA3. This is PA2 mode 2. This is PA3 mode 3. You're going to set bit 7 as 1, bit 6 as 0, because we're going to use that for receive as per the alternate function mapping. So as per alternate function mapping, we are setting PA2 for USART TX, PA3 we are using it for USART RX. So that's what I'm doing it here. USART 2 TX and USART PA3 as receives. So this means we have used alternate function. We set these 2 pins for USART TX and these 2 pins for receive. So that's that bit done. So now we're going to connect the LED as well. So that's on pin 10 and 11. PA5 as I said. From the schematics that you know, from the schematics, GPIO register on the porter mode, it's connected, the LED is connected to PA5, so that's PA0, PA1, PA2, PA3, PA4, PA5. So you got to set this motor 5, and what output type mode we're going to set, we're going to see that LED blink, so that is an output. So what function you got to write there has to be 0 1. So that motor, if it is 0 0, by default it's input. If you write that as 0 1, you can use it for general purpose output mode, and we used motor 3 and motor 2 for alternate function. That's why we have written 1 0. So the motor 5 we have to write 0 1. So the bit 11 is going to be 0 and bit 10 going to be 1. So we got to do that in the next example. So that's the next step. Copy. Backspace. The next step is this: configure the GPIO to output mode. PA5 for LED 2. So again you got to use LED on motor 5, which means these 2 bits 0 1, 11 as 0 and 1 as 10 as 1, so that will take as 0 1 general purpose output mode. 11 as 0, so that will be 11, and 10 will be 1. This means it's output. So that's the 5th step. And the 6th step will be, you got to set the output data register to blink and show that LED. So I'll go here, go here. Configure the alternate function for output function, GPI output mode, GPI to output mode first as alternate. So the next step is we need to set what type of the alternate function, because we're going to set that as USART2. So we're going to configure the alternate function to set AFRL register. Setting AF07 for USART2 underscore TX. Which is nothing but PA2. So you got to use that. So for that you need to use this register to set up. Copy that register, Control C, Control V, Control V, and I need one more of this AFRL. I'll tell you in a minute. Okay, so if you go back again to the AFRL, I'll go to contents, so that way it's much easier to show. So we are using the alternate function register low, GPIO alternate function low, GPIO alternate function low. So we're going to use, because we're going to use PA2 and PA3, PA2 for USART TX and PA3 for USART RX. So these bits 8, 9, 10, 11, this has to be connected to AF7. So you got to represent 0, 111 in here. 11 will be 0, 10 will be 1, 9 will be 1, 8 will be 1. And also PA3, we are using it for USART RX. So likewise, you got to use that 0, 111 here as well. 0, 15th bit will be 0, 14th bit will be 1, 13th bit will be 1, 12th bit will be 1. So that's what I'm going to write here. We need 1. Okay. So what do we need? First, we are setting PA2, that's TX. So 11th bit as 0, and 10, 9 and 8 will be 10, 9 and 8 will be 1, 1, 1. So 11 will be 0, 11 AFRL, 11th bit will be 0, and then 10th bit will be 1, then 9th bit will be 1, then the 8th bit will also be 1. So likewise, you got to configure for PA3. So I'll copy this, Control C, Control V. It's simple program. When you understand the logic, then you can follow and you would be able to write it immediately. And also it comes by practice. You have to configure which registers and then copy all the memory map address to it. And then if you simply know the logic, then it is much easier. So 15 will be 0, this will be 14, this will be 13, and this will be 12. So we set USART2 for RX, and this is PA3. Okay, we done that. 8, 9, 10, 11. AF4L, we have set those two. Now we need to configure the baud rate register. So I'll just simply copy this, be much easier. So the next step is configuring the baud rate register. That's the 7th step. On backspace, configure the USART baud rate. From the calculation, you're going to configure the USART2 baud rate register, BRR. So to do that, you need this baud rate register. Control C, Control V, and we already calculated from the formula, so you just have to write the value, the hex value directly. How did you get this value? If you go here, we did already the calculation, which is this value. You calculated for 16 megahertz with baud rate setting to 9600, and this is the value you get from the baud rate register formula. And if you convert this value to hex, this is what you get, 0 cross 0 683. So this is what you have to write here directly. So now we got to configure all the rest of the USART registers. So I'll just simply copy that, Control V, 8th step. You got to generate the baud rate registers. I mean, you don't need the TX and RX. Okay. Baud rate you have given there. Now we can just configure the USART control register. Control register 1, CR1. So for that you need this bit, control register 1, Control C, control register 1, and you're going to enable the T transmit enable first. So you just simply R with that, with this address 0008 0008, and this is for your transmit enable. Likewise, you need to enable for RxNE. Control C, Control V. USART2's, I'll check. Okay, USART. So I'll show you in the register. You go to USART, click on the contents. We are in reference manual. Click on the contents. Go to not general purpose. So you scroll down and go for USART. Go for USART registers, and go for USART control register 1. So we need to enable the first function you are writing TES1, so that will be 1000, so that is why I have written the last bit as 0008, and then you need to, that's bit 3. So bit 3, if you come down here, you got to enable the transmitter enable. So this bit enables the transmitter. It is set and cleared by software. Setting this to 1 is enabling, and also you need to do the receiver enable as well. So if you want to do that, receive enable bit 2, receive enable bit 2, you can write directly 00C, or you can also set this as 4, 0100, this will be 4. So RE receive enable, this will be 4. Either you can write it like this, or you can simply write with one command, just like this. Control C, just like this, and you can see instead of 8 or 4, you can also write as C. So this means it will know, the microcontroller will know you used TE enable as well and RE enable as well. So you can write it in one command like that, or you can separate it like that. So I think it's separate like that will get you more in-depth knowledge. So let's leave it at that. So the next step will be to enable the USART enable. So that will be your next step. I will copy that. USART enable. Configure the USART enable. Typing, fast typing, enable. Okay. So to do that, it will be 02000. I'll show you why, which bit. So if you go to the same register, control list 1, you got to enable the USART, where is it? USART 2, USART enable on bit 13. USART enable is here, bit 13. If you set this, then the value will be, the first bits will be all 0, that's 10, and then 0, and then 8, 9, 10, 11 as 0, and then you go into 0, 1, 0, 0, so that means 1, 0. So 1, 0 value is 2, and all the registers 0. So that's why you have to write here 0 2, meaning you got to enable bit 13 on USART 2 underscore. I'm just putting a reference so you know where to go, underscore CR1. CR1 register. Set bit 13 on USART1 register. Okay. So now we have written all the initialization, so we can go and do a right click and do a project build to see if there is any error, and then we can go in and to write the rest of the functions. So we got to now write the USART to write and USART to read. And if you'd like to have a short break, please go and have a short break. When you come back, I'm going to teach you, how to write the USART write and USART read. So I'll catch you back shortly. See you then.